Friday, yes, successful.
Alright, you gotta play the new Lego mode, Fortnite Lego mode.
Fortnite Lego mode is dope.
Yeah, screw Roblox. Or whatever we're playing on Friday, fuck that shit. We're doing Lego mode.
We're gonna do Lego mode Fortnite. All right. Yeah, if we have time, I'm down. I have to.
I'm telling you, it's worth your time. All right.
Gaming.
That's dope.
I have no time tomorrow, so if you're available tonight, I will do it with you.
I'll show you. I have a dinner date in 3.5 hours. So let's see. Let's see. He says, "Do I care?"
Just for like 1 second. All right.
What's up?
Hello.
What's up, Ethan? How's it going, bro? I saw you did well on your physics test. That's dope.
That's dope.
No, I'm kind of worried.
What are you worried about?
Because
what are you worried about?
I have only 1 week of school left to
I
do
know.
my best.
Yeah, good. You know, finish strong at the end. That's what we say. You know, gotta finish strong.
You know, I only got 2 A's so far.
2 A's is good. That's a good start, man. 2 A's are great.
That's the smartest person has 6 A's, which I don't know if I can get at this point.
It's okay. I always say, like, you don't need to, like, compare yourself to others. Like, just compare yourself to who you were yesterday. Like, are you doing better than you were yesterday? Then that's good. Yeah?
Doing a little worse, but
But overall, I think you're doing better, right?
Yeah, apparently, like, I've noticed for, like, the past month now, apparently my grades are kind of a bit higher. So
Okay.
it's like something in me is telling me that to keep going. I don't know what it is.
Well, I'm glad, dude. I'm glad you're doing well, dude. That's awesome.
That's dope.
All right. Let me see. I guess we want to play the new Roblox. Ooh, there's a lot of questions today. I love this. Wow, we have so many cool questions today. Noise. I like yours a lot. Bonjour, Teacup. What's up, Teacup? Good to see you too.
Noise just told me he apparently got a D in physics. I don't believe that.
You got a D in physics? Did you get a D in physics, dude?
I don't know. I don't.
What?
I don't know.
Noise, you got a D in physics? No, you didn't. Noise, you're too smart for that.
No, like he's telling me he did. He did. At the end of the day, this is your first time doing a proper physics class, isn't
it? Sure, FaZe. Are you in the Discord? Do you know? I mean, you can ask him here too. It's easier if you can post a screenshot in the Discord, but I'll do both. Here, let me start the stream off. All right. Welcome everyone to Actual Education. This is the Office Hours live stream. My name is Dr. Gold. It's Friday. We love it. Yes. Cool. I literally told you I got a D in my physics final last year. Oh, yeah, last year. But you were going through some shit last year, dude. It's okay. You're doing much better now, aren't you?
Yeah, I gotta hop off now, but I'll be back for my question.
Okay, cool. I think we're gonna play a little bit of Fortnite today because there's a new Lego mode or something.
Jeez.
I know. I'm sorry. I had to take my parents to the airport on Monday. Wednesday, I had to teach a student in OChem. Today, technically, I have to go on a dinner date, but you know she can wait. Hey, some shit for no reasons. Wait, what is FaZe? What is this question, dude? If 3 minus equals 12, what is the value of 82? 212, 44, 82. Well, first of all, what is that's 3 minus equals 12? What is those? Those aren't sensical things. I'm confused what that question's asking.
Base 8.
Surely it's D. Yeah, I think well, I mean, like, what's the question here, though? That's here. Let's see, one second. Let me pull this in, and then we'll do yours, Noise, because I'm curious about this. One second. Let me pull this in. Boom.
We're only working base 10s here.
We're only working base 10s, but like, yeah, what? Sorry, wait. What is this? This I don't understand. What is 3 minus equals 12? Is this supposed to be a thing? Oh, it's not showing full question? Okay, well, maybe try to write out the full question. Evening, Falcon! Good to see you. Or if you want FaZe, the easiest way is to join our Discord. Use hexadecimals for the numbers. Oh my god, no. If you join our Discord, there's a whole channel here where students post screenshots of the questions that they have, and then it's easier for me to like help you that way. All right, let's see. We don't need this one anymore. Okay. 3 identical magnets, P, Q, and R, release simultaneously from rest and fall to the ground at the same height. P falls directly to the ground. Q falls through the center of a thick horizontal conducting ring. R falls through a similar ring that has a gap cut in it. This is cool, actually. There's an effect to this, I think. In which order do the magnets reach the ground? Have you guys seen this video before? It's actually pretty cool. It's what is it? It's the dropping a magnet through a copper tube. Yeah, here we go. Let me show you this. This is a super cool one. It has to do with what are called eddy currents, which is pretty cool. But so it turns out that if you have a metal tube and you drop a magnet through it, it takes forever for it to come to fall through it. It doesn't fall through with the same. Look at that, like it floats down, right?
Do that again.
It's super cool. Woo!
That is.
Yeah, and the reason for this is due to eddy currents. So what you have is, if you have a magnet that's falling down through a conducting ring or whatnot, this creates there's a changing magnetic field within the metal, and that changing magnetic field drives a current, and then that current drives a back magnetic field which tries to oppose the motion. Is what happens. Please teach me. Yeah, you know, eddy currents it's just natural. You know, here we can get a picture of it. Maybe let's see, eddy currents diagram. I don't know if there's really like a calculation you can do per se in terms of like numbers, like what the eddy currents are. But yeah, in general, if you have this is the other one they do this. This is the other cool thing. I think they use this. I forget what they use eddy currents for. Maybe you can create like a break. I think you can create like a magnetic break out of it.
Maglev trains?
Yeah. Bro, stream is dead. What's wrong with my stream, dude? What are you saying? What is a Moog saying? Stream is dead, dude? Come up here, dude. What are you talking about? There's one person? No, there's 8 people in the Twitch. Yeah. There's 8 in Twitch. It's okay, dude. Yeah. Anyways, so yeah. So eddy currents are just currents that get created because you have a magnetic field and that's moving in a metal. That's how it works. Okay, so but I think you need it to be connected in order for that eddy current to happen, right? So I think that this one and this one will be the same, and then this one will be slower. So P and R should arrive together, followed by Q. I believe it's this one. Because I don't think this makes a difference if it's not connected. It's for math stuff. Okay, cool. Is that correct? I think that's correct. Noise. You let me know. I'm pretty sure it is. But yeah, good question. I like that one. Yes, correct. We love it. Yeah, dude, this is cool. You're taking my favorite part of physics was E&M. I really liked E&M. That's what got me into plasma physics in grad school. I was like, oh, E&M, because plasma physics is like the coolest parts of E&M. Is what it is. Did you see the inductance question? I did. Yeah, that was that's a tricky one. That's a non-homogeneous. I think it's a first order differential equation though, right? Magnetic fields are bad, dude. Okay, here we have a question from someone a first time question from someone in the chat. So I usually give priority to people who've never asked questions before. So let's try to solve one of these real quick. Non-homogeneous linear force. Oh, you're Abby. Okay, cool. What's up, Abby? Physics question here. Neil throws a ball to a friend 45 feet away. Neil threw the ball exactly the same way to his friend on now both the moon where gravitational acceleration was that. Oh, that's interesting. They put it in feet per second squared. Ew. So the distance apart was greater. What is the percentage difference between the friends? Throws a ball 45 feet away. Neil threw the ball exactly the same way. Oh, this is cool. So I guess what's happening here, right, is you got Sir Neil, right? And then you have whatever, this person, right? Friend. And he's got to be throwing the ball at like some sort of angle, right? It's got the ball probably has something like this. It has like an angle theta, and it ends up doing this. Well, here. Right. Okay. And this is a cool part about kinematic motion here. The projectile motion, things in the air, free fall, is the amount of time it takes for the ball. Here, let's draw a little ball first. Let's say we have a ball right here. The amount of time it takes for the ball to go up and down is the same amount of time it takes for the ball to go from left to the right. So you can calculate. So the amount of time that something does this is the same amount of time that it's going to travel in this direction. And what happens on the moon, where there's less gravitational acceleration, is that the ball spends more time going up and down because it's the gravity is fighting it less. So what we need to do, and the amount of time it takes for something to go up and down is going to be directly proportional to the amount of time it takes for it to go to the left to the right. Because if this is a distance here, right, this distance is going to be equal to Vx times t, right? So the velocity in the x direction times t. You're allowed a calculator? Yeah, you do need a calculator for this one. Okay. Whereas this distance, which let's call this like the height, right? That's going to be equal to the equation for this, I think, is like square root of 2g over h or something. But it really works like this. It's h is equal to h naught plus v naught t plus 1/2 at squared. Oh, yeah. Good. So, yeah. 2h over g square root. And then wait, we have to minus. Oh, actually, no. Sorry. This becomes a. This is a little bit true. Whoa, wait. The amount of time it takes for it to go up is the same amount of time it takes for it to go down. Yeah, the way to do this one is this one. Okay, sorry. It's v squared is equal to v naught squared plus 2a delta x, right? So this distance and these velocities are going to be the same, right? It's the same velocity going up, same velocity going down. Or actually, we can just set it equal to 0 and just multiply it by 2. Right, okay. We're going to get that delta x is equal to v naught squared over 2a. And then we're going to multiply by that 2. So it's just this. Okay. There we go. So this is the equation for the amount of distance that something will travel up and then something will travel down. And they say that we're throwing something at the same angle, so this distance has to be the same. Well, wait a minute. One second. Well, actually, no, it's not going to be the same. It's not going to be the same. Let me think. I think I want to do this. It's actually kind of a tricky question. Yeah, let's solve for the time. That's what we have to do. And then this is 5.33. So it's here. So gravity on the moon is equal to 5.33. Gravity on Earth is equal to 32. Okay. So the amount of time that the ball spends in the air, let me think. And yeah, let's just say it goes, it's sent at some initial velocity, v naught. Okay. So we're gonna have the distance is equal to V naught T. And then this is going to be minus 1/2 G T squared. Okay. So then 1/2 GT squared minus V naught T plus D is equal to 0. And so then the time for this is going to be a quadratic equation. My mass is lighter than the moon. Yeah. Okay, yeah. So this is a quadratic equation where, right, this is A, this is B, this is C, technically, right? It's a negative B plus or minus the square root B squared minus 4AC all over 2A. So that's going to be V naught plus or minus the square root of, and it's going to be V naught squared minus 4A. So that's going to be 2G, right? Because 4 times that, yeah, 2G. And then C, 2GD all over 2G. Ah, this is interesting. Yeah. FaZe, what's your name on Discord? And you have to you have to ask an actual question. The other question you asked, I didn't understand what it was. Okay. All right. Okay. So this is equal to the this is the time. This is what we say. This is the time in the air. Which, okay, so the time in the air for the moon is equal to all this, where in this case, G of the moon is 5.33. Right, and this is 5.33. Whereas the time in the air for the Earth is equal to all this. Oh, here, let's just copy this down. Where this is now going to be equal to 32. And then, let me make sure we did this right. 1/2 G to X equals negative B squared minus 4AC. Oh, and then this, they're minus 4AC. This is a positive. Wait, minus 4AC. Oh, we already accounted for the negative. Cool. Awesome. What's up, Rip? Good to see you. Oh, Diva. Okay, cool. Cool, Diva. I'll find you. Okay, so we want to know what's the difference between these two, right? Cool. Yeah. And then this is the... Oh, we want this to be 0, though, I think. Yeah, wait, one sec. D is equal to 0. Because I want the ball to go up and then to come down. So the initial height and the final height are the same. Okay, so this is 0, actually. Ah, okay. Well, if this is 0, because D is 0, okay. This goes to 0, this goes to 0, okay. Now this whole thing goes away, all right? We don't even care about this. So now the only thing that's determining the time is this bottom factor here. Oh, which is linear. Okay, cool. Ah, okay. So if we look at the ratio of this, let's say time on the moon divided by time on the Earth. This is V naught over 2 times 5.33 divided by V naught over 2 times 32. Okay. These things go away. These go away. And so we're just equal to 5.33 over 32. So that's the ratio of the time on the moon to the time on the Earth. And the amount of time that the ball is in the air is directly proportional to how far the thing is being thrown. Or actually, it's 1 over this. It's 1 over this. Sorry. This is on the bottom. This is on the bottom, so they flip. So it's 32 over 5.33. Okay. So it's just whatever that is. So here, let's pull a calculator out. Da-da-da-da-da-da. Cool. All right. So, calculator. 32 divided by 5.33. So your answer should just be 6. Okay. So it's going to be 6 times the distance. So yeah. 6. This is around 6. So 6 times further is what we would say. I think that's what the question I was asking, right? What is the percent difference in the distance between the friends? Okay. So if it's 6 times greater, right? The percent difference there is 500%, right? You can think of it this way. So if something, is 6 and something is 1, right? This is 6 times bigger. But the percent difference is 6 minus 1 over 1, which is equal to 5. So it should be 500%. Does that make sense? Who was asking this one? Abby. Does that make sense, Abby? This is kind of like this is kind of a puzzle. Yeah. Okay, let me move this over so this looks better. Streamer schedule. Yeah, just want to know our schedule. It's right here. There's our schedule. Yeah, there's the stream schedule. So this goes away. This goes away. Okay, cool. Good job, dude. So let me save this as long as who else is one? This was Abby. Cool. Abby. Oh, Himega wants to say hi. What's up, Himega? What's going on, dude? A lot of people in the.
So cool stuff. I am.
Are you still
actually have a little bit of
are you still playing football?
That season football season ended for me. I'm now in club wrestling. I did school wrestling for a little bit and then.
Okay,
now I'm in
wrestling's
club.
dope. I like wrestling. Wrestling is cool.
This is my first year in sports and I'm really enjoying
First
it.
year in sports.
That's dope.
I like sports. I was never very good at them in high school, but I do like them.
Yeah.
Nice. That's cool, dude. Have you played the new Fortnite? I heard the Lego mode is like really cool.
Yeah, Lego. I've played the new Fortnite.
Nice,
cool.
dude.
I have like weekends off and off like Friday through Sundays off.
Okay. Friday, yeah. Oh, that's good to have Fridays through Sundays off. You gotta have some time on the weekend to enjoy yourself, right? Let me see. Teacup has some good questions. Yeah, and this is a good one. Coefficient of friction with 2 things. Yeah, a lot of good ones. A lot of good questions here.
What game are you guys playing today?
We're gonna play Fortnite if we have some time. Hopefully,
Oh, yes,
there's a
we
new
do.
Lego mode.
Yeah, I have
that
time.
came
I
out.
have plenty of time.
Cool. Yeah, I think if I can wrap these questions in the next like hour, I'll probably do some Fortnite with you guys. How do I get a bomb point I need for a prize? Ask a math or science question. Phase. That's what you do. It's in the Discord. It's easy. If you want to see how that works, yeah, look, like this is in the Discord. You can send a screenshot of like one of your homework questions. Like Noy sent this screenshot and we went over it. And now, let me see. Here, I'll go in order. Teacup, you here? I'll do yours. I'll do one of yours, Teacup. Teacup. Makes me tag him sometimes. One sec. Teacup. There you go. I'm tagging you there. And then Ethan has a good one too. And then yes, I see yours, Nick. I see yours as well. No, I don't need this. I don't have that much hard questions. It's okay. You can ask me something that you're going over in your math class, and I can come up with something that's more difficult. Your headset doesn't want to work. Okay. All right, that's okay. Well, we can just go through your questions. That's fine. Okay, cool. All right, this is a good one. This has to do with what's called L'Hopital's rule, and limits. Sensation, have you ever had to deal with limits? Have you ever do limits yet?
Fairly certain that's A level too.
That's A level, yeah, right? Yeah, limits are cool, man. Limits aren't that tough, you know? Like, here's like, you know, I'll give you a little crash course in limits, right? Let's say, for instance, they say, like, what's the limit as x approaches 3 of 3x plus 2? Do you know how to do this type of question?
Not a Scooby.
Not a Scooby. It's not that bad. So what this is asking is, like, what is the value of this as x gets closer to 3? That's all this is. You know, I know it looks like scary math stuff, but it's not that bad. So if you were to, like, graph this, right? As a graph, this would look something like this probably, right? Let's say this is like 1, 2, and I don't know, you know, just right. So what they're asking you to do is that if you were along this line, 3x plus 2, this function, and x started getting closer and closer to, let's say, 3, they're asking what would the y value go to? That's what a limit is. It's not on standard A levels. There's a section on limits as an option for further maths. That's it. Okay, that's interesting. Yeah. So the easy way to do limits is to first try to plug the number in and just see what you get. So if x goes to 3 in this equation, right, what does this whole thing go to? Like, what's the value? Right, if this goes to 3, Sensation, what does that become?
The maximum value, so that's 11, isn't it?
That's 11. Yeah, exactly, dude. Easy, right? Yeah. That's limits in a nutshell. That's easy limits, okay? Limits can then get harder because we have what are called discontinuities. An example is, yeah, let's look at this one for example, this top one here. So in this case, again, they're saying limit as x approaches 3 of this thing. So the first thing you can try to do is just plug in 3 and see what you get. So in this case, you get 4 times 3 minus 12 over 3 squared minus 5 times 3 plus 6. This gets you 12 minus 12, which is 0. Okay, cool. Over, right, 9 minus 15 plus 6, which is also equal to 0. So it gets you 0 over 0. Do we know how to do 0 divided by 0?
Well, isn't anything divided by 0 not a number?
Yes, exactly. It's well, things divided by 0 are, I think, infinite, technically. Or is it indeterminate? Is that what they call it?
Undefined or something.
Undefined. Yeah, I think it's undefined. Someone was like, there's a difference between something being indeterminate and undefined. And I was like, cool. I'm just like, well, you can't really write them down, I guess is what it is. So yes. Yeah, I think it's undefined is what it is. But okay. Yeah, you're right. We don't know what anything divided by 0 is, and 0 divided by 0 is kind of weird, right? Because we're like, how many zeros go into 0? You're like, a lot of them? None of them? I don't know. So the way to do this type of question when you have something, when you get 0 over 0, is to do something called L'Hopital's rule. L'Hopital.
Bonjour, monsieur.
Bonjour, monsieur. Yeah, Teacup. This is a very French name, right? L'Hopital's rule. Look, it's got like the fancy like comma and like the whatever. I don't know what that symbol's called. But here, here's the formal definition of L'Hopital's rule. It's pretty cool. Okay. Let's copy it in. This is the formal rule, which says if you have the limit of a function on the top and a function on the bottom. So such in this case, right? We have a function on the top and a function on the bottom. And it becomes 0 over 0 or infinity over infinity, then what you can do is take the derivative of the top and the derivative of the bottom and then evaluate the limit and see what you get. And whatever that is what the thing before taking the derivative was. And sometimes you have to do this a couple times because you have to keep going until you're no longer getting 0 over 0 or infinity over infinity. So, in the case of this one, like let's do this first one. I see that I have 0 on the top and 0 on the bottom. Okay. So, Teacup, what would I do using L'Hopital's rule? What does L'Hopital's rule say that I should do if I have 0 over 0?
You set it equal to limit f prime of x over g prime of x.
Good. So f prime of x, right, means taking the derivative of the top. So what's the derivative of the top here?
Well, let's do, so we'd have 4x to the 0.
Good, 4x to 0. And what else, sorry?
Well, then it's just negative 12, but that's...
But what's the derivative? Yeah, what's the derivative of just negative 12? What's that?
Isn't that just 0?
Yes, just 0. Good. So this just becomes 4, right? All right, then what does the bottom become?
Bottom, we have... Okay, we got 2x
Good.
minus 2x plus... Oh, wait, 2x plus 2x minus 4.
Where's the
No,
4
2x
coming from?
minus 5.
2x minus 5. Yeah, good. All right, you see how this doesn't do anything? This goes away?
Yes.
Okay, cool. All right, so now I can try plugging in 3 and seeing what I get. So what do I get when I plug in 3 now?
2 times 3, so we have 6 minus 1, that's 4 over 1, so that's just 4.
4 over 1, right, which is equal to 4. So this is a number that's not 0 over 0 or infinity over infinity. It's like a nice thing. Good. So we say that this limit, right, is now equal to 4. That's what it is, and you're done.
So limit x to the third, limit x as it nears 3 is equal to 4.
Yes, there you go. Good. Good stuff. Cool, Diva. I saw it. Yeah.
I can't boost the server anymore.
Your nitro's about to run out?
No, my nitro did run out.
Oh, okay.
So I can't boost anymore.
We'll do a nitro giveaway because yeah, I do need 2 more boosts on the server. So
Like, I'm probably not gonna win. So
well, Amog won it last time I think because he's boosting the server now, or I think Redacted did, but then Amog won it or something. So yeah, I'll give out Discord Nitro at the end to celebrate Friday. We like Friday. Friday's dope.
That's dope.
Okay. Let's try this one. Teacup. Let's try this one. Who got Halo theme? Is Master Chief gonna come out? Oh, there's Master Chief.
right, so we have limit x equals -2. So let's do L'Hopital.
Well, we need to first see if we need to do L'Hopital's rule. Okay.
Well, if we just plug in 2 for everything, so that's 2.
Well,
2
negative
to
2. You plug in negative 2.
Negative 2. So
Yeah.
we have -2 to the third.
Yeah. Good.
Can we just do the calculator? I don't want to calculate all this.
I'll just do it. Okay. This is gonna be -8, right? Plus, plus 8, right? Plus 2 minus 2 over
Yeah,
what
we're
is
gonna
it?
need L'Hopital.
We're gonna the top is 0. That's correct. We gotta check the bottom. So this is 16 minus 16
Yeah, we're gonna need a
plus 8 minus 8. Yeah, you're right. This is 0 over 0. So this is bad, right? But yeah, the cool thing is we can use L'Hopital's rule to do this, right? Okay. So what am I gonna do?
It's the hospital. It's not pronounced.
I know it looks like the hospital rule, dude. It really does.
That's what it is.
Dude.
L apostrophe is the, and then you have hospital.
Yeah, I
which
know
is
it looks like the hospital rule. Yeah.
So it is the hospital.
No, it's not the hospital rule. It's not the hospital rule.
That's what it is.
Okay. Got Mr. Halo here. Hold
Oh,
on.
oh no, it's hola.
Hold on. Okay. So what do we do? How do we use the hospital rule?
So we take the derivative of the top and the
Good.
derivative of the bottom. And
Good.
plug
So
it back in, and
what's the
then
derivative of the
we do it
top?
again.
What's the derivative of the top?
Well, we got 3x to the second plus
Good.
4x minus 1.
Good. Don't worry about this
And
one,
then
right?
we have 4x third plus, what is that, 2 squared, 2 cubed, what's that, like
6x squared.
12,
6x squared.
6.
Because the 3 comes down,
And then
right?
we have minus 4.
Good. Okay. Now watch what happens if I plug in -2. See how I
If
get...
it's still,
yeah?
if it's still the same after plugging in, we do it one more time.
Well, and I don't think we're going to need to actually here. Because this is 12 minus 8 minus 1, right? Did we do this right? 3x squared plus 4x minus 1.
Teach minus
Yeah, it looks
1.
okay to me so far, right? If I plug in -2, this is going to be -32 plus 24 minus 4. Okay, so this is good, actually. This is all right. I thought we were going to have to do it again as well. Yeah. Yeah, this is good. This just gets us 3 over -12. So what is that? Yeah, it's -1/4. Cool. But you're right. If we had taken the derivative and we still got 0 over 0, we would have to do it again. Yeah. Nice. Good job, Teacup.
That's dope.
Learning all the stuff today. All right. 1 user to Teacup. Noise, have you had to do L'Hopital's rule yet for your A levels?
Alright, to the Olive Rock.
Are you gonna? I think we're gonna maybe play some. We're gonna play some Fortnite later. If you want to play with us, Be fun. Or stick around for the Nitro giveaway.
I'll stick around for the wheel that I won't win. But
You win the wheel. Don't worry, dude. Right here. Let me help.
listen, bro, I just want my Nitro.
He says, "I just want my Nitro." All right, here. Let me help out Ethan with this one. This is kinetic friction in this. This is a good question, Ethan, but I got to teach you some more stuff first. Yeah, Ethan, what's up? Are you here?
Yeah.
Yeah. Yeah, let me teach you some more stuff. I mean, this is a cool question, but we gotta walk before we can run, type thing,
What? I don't even know how that works.
Like you have to learn the basics before you can learn the more advanced stuff. That's what I say. Here, let me get you a question real quick. What is? Yes, FaZe. I saw your question. Yeah. Yes, what's up, dude?
I feel like my life is just hard for now.
You feel like your life is hard right now? Yeah, my life is pretty hard.
Yeah.
Yeah, life gets difficult
I
too.
mean, I'm stressed out.
Oh, you're stressed
I'm
out.
stressed out.
Yeah, no, that's totally normal, Ethan. Like stress definitely happens. I'm stressed out. What we do with the stress is what's important. It's okay to be stressed out. Stress happens a lot.
It's like my life is on the line with the A's right now.
Yeah. Well, just believe in yourself, dude. You're gonna do well.
I just feel like there's no hope now.
Well, if you believe there's no hope, then bad things tend to happen, I guess. Yeah, I get it, Ethan. I mean, it's a common thing in life for that to happen, but trust in what I like to do. Look at all the cool stuff you've done in the past. Like, look at all the good grades you've gotten before, and that should make you feel better about the good grades you're going to get later. Man, do they have just like a basic Atwin machine question? I just want a basic Atwin machine. No. Tension in string 2 blocks being pulled. Example. One example question. Here's one. Aha! I like this. That's a good one. Okay, here, let's do this. This is a very good question here. Who's posting all these screenshots? Oh, noise. Oh. They only work in right angle triangles. Oh, you're helping Nick out. Oh. Can you be helped? That's how. Good explanations there, Noise. I like that. I'm a 7th grader. Yeah, it's all good. I can teach you more stuff. Okay, here, Ethan, let's try to do this question. This is a good one right here. I like this one. Okay, so it says 2 blocks, one of mass 3 kilograms. Okay, so this is going to be a 3 kilogram. What's up?
Can I say something?
Yeah, what do you want to say?
It's kind of like a story. Do you mind if I say it right now?
Let's talk about it during Fortnite, just so I can make sure I can get through all your questions. Is that cool?
Alright.
All right. Here, let's try this one. All right. It says the magnitude of the tension in the rope here on the left is 6, and then we don't know the tension in the right. This is unknown. But they tell us that the acceleration of the blocks is 5 millimeters per second squared towards the right. Okay, we're saying that A is equal to 5 here. And they want to know what's the tension of the force in the right.
There.
Sorry, what?
You could just put TR there.
Yes. What do you mean TR? We're trying to figure out what TR is.
Like on a, yeah. So why don't you put TR is equal to 5m/s squared?
No, TR is not equal to 5. No. The acceleration is equal to 5. That's different. These arrows here, Ethan, represent forces. This is representing what an acceleration is. Okay?
No.
All right.
Okay.
So the way you do these questions, so there's an easier way. There's an easy way to do this that would take like 2 seconds, but then let me show you like the hard way, and then the easy way, you'll appreciate it more. Okay? So the way to do these types of questions is to draw what are called force diagrams. You've drawn force diagrams, right, before?
What are force diagrams? I need like a refresher if I did.
So it's you draw what the object is, and you write out all the forces that are acting on it. Okay?
No. Like, see, maybe I did do that in like sometime before, but I was just learning the basics, like
That's okay.
about all the type of forces, like gravitational force.
Yeah, that's why we're we're relearning things and whatnot. So you remember it.
Alright.
Okay. All right. So if we look at the block here, right, the 3 kilogram block, right? What
Yeah.
forces are acting on it?
The 3 kg block. Well, there's obviously the force on the left.
Good. There's a force to the left, right? This is gonna be TL,
It's just 6.
which is 6. What are the forces there?
Maybe acceleration due to gravity, which is just negative 9.81.
Good. This is negative 9.8. Yes, good. Well, this is the force of gravity, which is equal to negative 9.81 times the mass times the 3.
Alright. Wait, where does it? Oh, right. I was wondering where that tree came from. It is the mass.
Well, okay. We don't need to do the minus because the minus just tells us whether the arrow is going up or down, and we've already drawn the arrows going down. So you can just leave that as you don't have to put the minus in it.
But will the answer still be correct?
Yes.
Alright.
Okay. And then yes, there's what's called a normal force. Normal force is what keeps
Yeah,
this.
I know that.
Okay. What's the other force?
Like, it is obviously the normal force, like you just said, which, if I can recall perfectly, I think they have to be kind of the same. So it's like
Yes.
9.81 times 3.
Yes. Good. Yes, and that'll be in the opposite direction, right? Those are gonna be equal to each other. All right. But what's another force acting on this block? What else is attached to this block?
Right, the tension on the other one.
Right. There's this rope here in the middle. Okay. We're just gonna call that call that tension. Or here, let's call that TM, like the middle tension, right? This is the left tension, this is the right tension, this is the middle one. Okay?
Alright. Yeah.
All right. So then what we do is we draw a force diagram for the right block. So let's do the right one. Come on. Okay. So it's going to have the same stuff, right? Force of gravity. That's going to be equal to 9.81 times 4. It's going to have the same normal force, which is going to be equal to the force of gravity pulling it down. It's going to have now a TR to the right, which we're trying to figure out. We don't know what that is. And then what's another force acting on the 4 kilogram block here?
There is the acceleration due to gravity again times the mass.
Yeah, we
which
already
is
did that.
4 this time.
We did that. We did this. There's one last force missing on this.
Hold on. I think your screen froze for me. Hold on.
It's okay.
Hold on, let me try to refresh it. So it's just I think the only force left is just the TM, the tension
Good.
in the middle.
And that one's going to point to the left, okay? Because now the
Yeah.
tension's kind of like
Yeah.
pulling this thing back, right? The cool thing here,
Yes,
Ethan,
that's it.
is that the tension here pulling the 3 kilogram block to the right is the same tension pulling this 4 kilogram block to the left. Like the tension in the rope is the same, and it just goes in opposite directions. That's a key physics thing we got to remember.
I'm so sorry that my internet's kind of acting bad right now.
It's okay. Okay. The last thing to do, well, not last thing, but the next step is to use Newton's laws, which says that the sum of the forces is equal to the mass times the acceleration.
That's not the acceleration.
Good. Okay. And we really only care about stuff in the x direction. We only care about stuff really going this way because nothing's happening in the y direction. Okay. Later questions we'll have to do it. All right. Okay. So if we write out the sum of the forces in this case, right, we're going to have Tm, right, minus 6 has to equal the mass of this object, which is 3, times the acceleration of this object. What is the acceleration of both of the blocks? What did they say the acceleration was? Five! Yes, good job, Sensation. I like it, dude. Yeah. So, yes, times 5. Good.
Sorry, I was muted. I was supposed to say 5, but
It's okay.
yeah.
So then the same thing here. So TR minus TM is going to equal to 4 times 5, mass times acceleration. Okay?
Mm-hmm.
So you see now I have 2 equations. Okay?
You can see that.
So we have TM minus 6 is equal to 15. And we have TR minus M is equal to 20. Or minus TM, sorry. Not minus M. Minus TM is equal to 20. And we're trying to solve, right, for TR. How do you think we figure that out? We have 2 equations here.
Don't you try to combine them together to make them the same or something?
Yeah. We could add these 2 we could add these 2 together. This is called the elimination method in algebra, right? So we do this
Is it
plus
like
this.
Stuff equations, the simultaneous
It is.
equations?
It is a simultaneous equation. Totally is. So this is right.
Okay.
TM minus 6 plus TR minus TM is equal to 15 plus 20. See, I just added these and I added all these, right?
I can see that.
So the very cool thing here is TM goes away. See how we get a plus TM minus TM? We don't need it anymore.
I can see that. I can see
Cool.
that for sure.
Yeah. All right. Good. So then I have, and then let's add the 6 over here, right? So this gets me TR is equal to 41 newtons, and then you're done.
All right.
Pretty easy. Yeah.
All right.
The even easier way to do this one would be to consider this whole thing to be a massive big block of just like mass 7 that we just combined it, and then have this be 6 newtons this way and this be the TR, and then this is just TR minus 6 is equal to 7 times 5, like the acceleration. And this would get you the same answer. TR is just equal to 41. This is the super quick way to do it. But I wanted to show you this way of doing them individually because sometimes we're going to have things like friction or other forces acting on the blocks independently, and you want to be able to do that. But you get the same answer.
All right.
Yeah.
See, the question's a bit snide with the connection between the 2 blocks. Third rule of motion applies.
What's the third law of motion?
For every action is an equal and opposite reaction.
Exactly. No, you're totally right there. And the equal and opposite reaction, right, is kind of the tension, this stuff in between, right? Like every tension The tension on the rope pulling the block to the left block to the right is the same tension pulling the right block to the left. Yeah. This is cool. Do you
Exams are like that? They're sneaky.
Yeah, they're sneaky. Did you do any physics like this in your A levels, or what are they called?
GCSEs. This, yeah, well,
yeah, you have to do a little bit of this. Yeah, that's cool.
I got a G like, but whatever.
Nice. Good job, Ethan. Ethan, good question. Cool. Sick. All right, here, let me help out. I think Noise helped out Nick. Nick, did Noise help out all your problems? I'll do Diva's question. Diva has probably a fun one. This is cool. I like this. Yeah, this is good. This is a good question.
Alright, so,
What's up?
I just pray to God now that I do well for this last week of school.
That's cool, man. Yeah, I think you're gonna do well. I know you're gonna do well, Ethan.
Like I've done so bad in some subjects. I really can't do anything now.
It's okay. You can do better next year. That's the beauty of things. Is that, you know, as long as you never quit, you can always do better.
Be like water.
Yeah, what's the one? Be like water, flow in what? What is it? What's that quote sensation?
I can't remember. It's like if you put water in a cup, it becomes the cup.
Oh,
If you put
yeah.
Water in a kettle, it becomes the kettle.
Be like water quote. Where's this one? I want this quote. Dude.
Water can flow or it can crash, and I've forgotten the rest of the quote. So
Yeah, be like water making its way through cracks. Do not be assertive, but adjust to the object, and you shall find the way around it or through it. If nothing within you stays rigid, outward things will disclose themselves. Oh, it's a Bruce Lee quote. That's cool. I didn't know that. Bruce Lee was dope. Be like water, my friend.
I've got a copy of oh my god, I forgot the name of the book now. I've got so many books. Jeet Kune Do something. Crap.
Oh, what? What was it? Bruce Lee.
Tower Jeet Kune Do. I can see it from here.
Oh, okay. Is that a type of martial art that he does?
Jeet Kune Do is what he invented.
Oh, he invented it. I'm seeing Bruce.
Where he fought somebody and broke his back, and then he wrote the book.
Oh, here it is. Yeah. Jeet Kune Do. Oh, very cool. I mean, he eventually.
Some interesting philosophy.
What? So sorry. His son died, right, from like a fake gun on a movie set for The Crow, right?
Yeah.
But how did Bruce Lee die? Isn't there? There's like some weird there's some weird coincidences. You know what I'm talking about?
It's not as nice as the stories might suggest. I mean, it would be nice to sit there and say, "Oh, the demons got him eventually," but I think
no, Curse of the Dragon.
Possibly have been.
Yeah, this is it. This man, there's some. It's like there's a lot of similarities between their deaths. Yeah, both of them died while working on their 5th film. And then yeah, it's something about
cerebral edema.
Yeah. Anyways, there's some there's like a curse or something to it. Yeah, anyways. It's cool. Okay. Deba, what's up? Is Deba here? Deba, where you at? Good news, Falcon. Oh yeah, and then Falcon, I want to go over your statistics thing, which is cool. Deba. Here, let's do your question. Entire 10th chapter of my stat book will not be on the exam. Ooh, we like that. We do like that. Oh, let's see if Deba wants to come around. That full chart. Yeah. Okay, cool. All right, here, let's do this question. All right, Deba, do you know how to do this one? This is a good question. This is multiplying exponents. I go over this actually a lot with students. It's a good concept to always refresh on. Do you have a mic, Deba? Do you want to come talk with us? You can come talk with us on the stage if you want, or you can just chat. You can chat right here if you want. Doesn't matter. The Discord's faster though. So yeah, either chat on the Discord or you can come to the stage. Whatever you want to do. I will chat. Chat is cool. We like chat. Yeah, Falcon, have you done this one before? What's the answer, Falcon? You know how to do this? All right, so chat. So Deba, do you know how to do this one? Nice, Falcon. You don't really know? Okay. This has to do with multiplying exponents together. It's new. Okay. Well, here's the rule here. If I have x to the a times x to the b, this becomes x to the a plus b. All right. So if I have like two things that are the same base is what we say, and they're being raised to different exponents and they're multiplying by each other, you can write it as a single base to the exponents added together. So Deba, if I had, for instance, x to the third times x to the fourth, what would this be equal to? X to the what? This is where I think like Sensation's gonna like come up with his hands. He's gonna do like, what's the number? Sensation's like, it's at 5, 6, 7, 8, 9. Oh man.
I only interjected before because it was just like we can't sit here forever waiting.
Yeah, no, I could only it's funny. I only noticed because like I saw in my peripheral that something was happening on the screen. I was like, oh, that's the Sensation waving his hands. Yeah. But yeah, Deba, what is this? What if I have x to the third times x to the fourth? What do I get? X to the what? X to the something. You don't know? Okay. Well, let's help you out here, man. So again, x to the something times x to the something else is x to those exponents added together. So in this case, if I have x to the third times x to the fourth, this is x to the 3 plus 4, which is the same thing as x to the 7th.
Yeah, that's what I was thinking.
Yeah. You know this, Omega, right? You've been doing this, yeah?
I've been doing multiplying integers, and we're just now getting into like multiplying like numbers.
Yeah,
different
exponents and
variations
stuff.
of 'em.
Yeah. Falcon says he's got this one. Okay, cool. Let's see Falcon. Falcon, let's see if you got it right. Okay. So this can get more complicated. We could do something like this. I could say x to the fourth, y to the third, times x to the second, y to the fifth. Yeah, I think that's right, Falcon. We'll check it.
Wouldn't y to the third plus it would just be y to the third plus y to the fifth, so
Good.
it would be 5. It would just be 5 plus 3, which is
Good. Good.
So it'd
So-
be y eighths.
Y eighths, but then what about the
to
x's? Yeah, don't forget the x's though. I mean, you
You
should.
have to add the x's.
Good.
Together.
So that becomes x to the sixth. Do you see how we add these two together? This is the cool thing. This is called the I think it's called the commutative property of like math stuff. But when you have stuff written like here and they're all multiplying by each other, you can reorder the multiplying. So I could write this as x to the fourth. So really what this is x to the fourth times y to the third times x squared times y to the fifth. And you can reorder these to make this x to the fourth times x squared times y to the third times y to the fifth. And now you group these. And you're like, oh, cool, this is x to the sixth. Cool, this is y to the eighth. And that's how they work. Yeah. Okay, so in this case, yeah, in Deba's question, right? Now we have an additional thing that makes it kind of trickier. Do you know how to do this one, Hamega? Do you know what the 7 and the 4 does?
No, I don't.
Okay.
I'm not even listening. I'm playing a Fortnite game right now.
Okay, it's all good.
I kind of just
It's all right.
listened to you guys with
Okay.
that. That was kind of.
I like that. It's called it's like learning by osmosis. Like eventually you'll hear enough math stuff that it's just like hypnotizing you. You know, it's like brainwashing, but good brainwashing.
It's one of my favorite subjects. So.
We do like brainwashing. Yeah, but yeah, Falcon has this.
And that's just me.
He says it's me, Sensation.
A cigarette in one hand, a cup of coffee in another, paying as much attention as I possibly can. Must learn everything.
But yeah, it eventually will stick. Yeah, learning by osmosis. Yeah. So, yeah, so what happens here when we have this is this can be written as 7 times, well, sorry, that's god ugly to walk. Okay, here we go. We could write this as 7 times 4. I can reorder the numbers being multiplied by each other. And then we can say times x to the third times y to the fourth times y to the third. And now I can group these, right? This is 28, and then this is x to the fourth, and then this is going to be y to the seventh, which I think, Falcon, that's what you had, right? Is that what you had? Yes. Yeah, without the minus. There's just no minus sign on it. Yeah. Yeah, exactly. Cool. All right, awesome. I swore the 4 was negative. Yeah. It looked like it was almost negative. That's good. Okay, cool.
Can't fight that kid.
Dun, dun, dun. I'll give one to Deba. I'll give one to Falcon for that. That was good. That was good, Falcon. Where was let me see. Falcon did post something. Yeah, this was all your homework, right? Here, let me copy this in. Oh wait, copy image. It's coming in. 1 second. Yeah. Oh, Friday. Okay, here we go. And then, yeah, and then we'll look at the other one. Look how you got it. Okay, here, pull it in. Okay, a little blurry, but I think I can read it. Okay, so 60 out of 70 is not bad. That's a good score, man. Ah, that's good. That's a B, right? That's at least a B. Yeah. Okay. Wow, and you had to calculate all this, dude, by hand, man. This is a pain, dude. Wow. Okay. Okay. Yeah, this was good. Yeah, good. You got SS in between the X's, between the Y's, between each other. That's SXY. Then you get a correlation coefficient. Very close to no correlation. I agree. Yeah. Usually we look at R squared is what we look at, right? So I still need help doing one about the mean value. If you could run over the key and the question with me. Yeah, sure. Let's look at it. So the mean value. I messed up with the X and the Y values. All right, let's see. Well, this looks okay. You're doing okay here. Right? Good. This is good equations for the coefficients. Cool. Gravy. This looks all gravy, right? This is all good. Okay. So is it, let me see. Is it the third page? 1 sec. Oh, it's the 10%. Oh, it's the 10% one. Yeah, okay, 1 sec. Let me pull it in. Got you. Okay, cool. And all right, cool. All right. Construct a test linear for the F distribution. Great. P-value. And we did it at 10%. So is this it? Is this the one? Is this one you need help with? This one here, Falcon? This one right here? Or was it the other part? I'm trying to see what part was it. Oh, okay. Wait. No, it was the confidence interval. It was the confidence interval one. Yeah, okay. I see which one it was. Yeah, good. No, I know what you're talking about. You're talking about this one. 1 sec. Let me pull it in. All right. The mean length of stay if 3.5 patients are registered. Yes, okay. So, what we want to do, right, is the confidence interval, right? Let me use a different color. Let me say like blue. Yeah, so confidence interval is always equal to like some mean value. And then it's plus or minus what we call like a standard error. Okay? So we want to look at the length of stay based on your based on what your equation was. Let me see. Where was is this the equation? Yeah, this was your line of best fit. So it was here, let me just grab this.
I just got my first crown win. Let's go.
Oh, nice, dude. Is this the new Lego mode that you're playing?
No, not the new Lego mode. This is just normal battle royale.
Okay, cool, dude. Okay, so here's what we want to do. So this is your equation, right? This y hat, remember, right, is the length of stay based on x, which is the number of patients per registered nurse. So we're just going to look at what we would get for 3.5. Like, so if I plugged in x was equal to 3.5, right? What does that get me for y hat? Oh, I've lost you already? Okay, no. Okay, so here we go. Okay. So let's go back to like the equation of best fit here. So y hat, right? That's the length of stay, okay? And then x is the patients per registered nurse. And so when you calculated a correlation to all this stuff, you had like a bunch of data points, okay? Bunch of stuff like this. Probably. Let me see. The slope is positive. So sorry. All right, let's do it like this. It's like this. Where the y-axis, right? This was the length of stay, and then this was the patients per registered nurse. Does that make sense so far? And then this equation you came up with down here, this looks something like this. So this is y hat is equal to blah, 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 x. Good? Okay. So what they want to do is they say, okay, cool. If I have 3.5 patients per registered nurse, right? What is the average amount of stay, right? The average amount of stay would be plugging in 3.5 in for x for this equation to then get the length of stay right here, right? That's what the average would be. But there's going to be some variation to that, right? There's some wiggle into like how confident I am that it's exactly, whatever this amount is. Because the regression line has error to it. It has wiggle, right? So, here, if we plug, this was the equation of our line, right? I can plug in 3.5, okay? So, let's pull out our calculator. Sorry, let me put this over here. Okay, so this ends up being, what is this? This is, so it's negative 2.89 plus 43.75 times 3.5. Okay. Was 43 really? That's a lot. That's 150. That doesn't look like anything like what the amount should be. The equation was a bit wrong though, because yeah, this equation is very wrong. Yeah. Because do you see if I plug in 3.5 for here, right? I get a much different number than I should be getting, right? Yeah. The equation's wrong. Because this was wrong. Okay. Do you have the key for what the actual equation like? Yeah, it's a crazy number. Yeah. Well, that's how you know you did something wrong. You can check. Okay. Do you have what the answer was for this? What the equation should be? Oh, you'll send it? Okay, yeah. Yeah, send me the key. Did you send me the key? Sorry, I forgot if you did. Oh, you did. Oh, no. I think you did. I think you did, man. You're good. I have it right here. Okay. Oh, I see. Oh, I think you flipped your B naught and whatnot. Okay, cool. Yeah, no, you're good. I got it, Falcon. So this is it. This is the equation of line. Yeah, all good, dude. It happens. Okay, so this is what we actually wanted to use. We want to use this equation. So yeah, so now if I plug in 3.5 in for this one, right? If I do what is this? This is 46.663 minus 3.5 times 3.617. That gets me a mean of 34. Okay, so that's what the regression line would predict. The regression line would predict for 3.5 patients per nurse that the average length of stay should be 34 days. Okay, so the length of stay is going to be well. Let's use different. Where's this blue? Right, this should be 34 days. Okay, that is the mean value of our confidence interval. So our confidence interval is going to be 34 days plus or minus some amount of error. Okay, and that error for 90% confidence usually means you're going to use some like T star value, right? Using a T table. I'm going to guess this is around 1.7. Let's see. We can see on the key here how they do it. So, okay, cool. So see, there's the 34, right? Then here's the 1.7. See, this is like the T star whatever over n minus 2. Yeah, okay. And then this is where things get weird. It's the standard error. Yeah. So this equation right here. I don't know necessarily where this one comes from. This looks like the standard error for it's some special regression thing, but usually it's just whatever the standard deviation is. And so yeah, hopefully they gave you this on like some sort of table or something. They should give you this. They should say like here's the standard error for y hat for a regression equation. I wonder if did they Yeah. Again, I haven't seen this. This is probably on some sort of equation sheet that you get. No table? Wait, so you're just supposed to know this off the top of your head? I do what? Excuse me, what? Yeah, I haven't seen this equation. I mean, like I could try to Google it. What would this be? This would be standard error for y hat regression. Let me just see. Yeah, here we go. This is it. And then, yeah, because he does 1 over n. Uh-huh. Oh, he has 2 standard errors. Wait, one sec. Is it SE? Is it B1? Let me see. Where do you get for SE for where do you get that point? Square root of oh, okay. So it's MSE. DF, degrees of freedom, sum of squares. M. Yeah, it's okay. Yeah. So the standard error, the wiggle, right, on that confidence interval in this case, this is equal to the Z star or T star, right, which is like 1.7. And then it's the square root of MSE times the square root of the error in B0. In B1. So this is the error in I think it's B0 is what it is, because that's what I see here. Yeah. It's the error in B0. So that's what this is. Yeah. And that's where he's getting that number from. I'm trying to think if Is this the same thing as like MSE? Yeah, you did calculate MSE. Yeah. I just want to see if it's the same thing. It's not. Mean squared error. Yeah. Okay. Yeah. Well, okay. Yeah. So for your test, when you take this one, Falcon, you just have to remember that. I would have, and again, I like this. I like that he said cute. Like, this guy just said he was. I'm glad you wrote down something, but best to like just remember like right what a confidence interval is, and so write out the mean value, write plus or minus, figure out T star, and then you can kind of bullshit what this is. At this point, this is like something like specific to this type of question. In regression, you need to remember it's the square root of MSE times the square root of the error in B0, which is what this thing is right here. But yeah, that's all statistics is. It's a lot of like really like specific situations and memorizing like which one you use for things. Nice. Okay, cool. Hopefully that helps you out. I know you got your test next week, right? Okay, then what was Artan asking about this? Where was it? One sec. Here, let me pull this question up. Makes sense now. At least more sense than before. Dope. Oh God, I'm glad it makes more sense. Yeah. I mean, all statistics is a bunch of like, there's a bunch of patterns to how things work, and it's as long as you know the pattern, you'll get enough partial credit that whatever he can knock you a couple points off for not doing the exact right whatever standard deviation or something, or maybe you had n-1 versus n-2. But as long as you get like the general concept of what it works, I think you'll do good. You'll do fine. So Artan was asking about this. Yeah. Okay. Here, let's see. And then I think that's the last question of today. Last questions. Yeah, Noise did a really good job. I appreciate you, Noise. Thank you for here. I'm gonna give Noise a Boncoin for answering questions for Dark. That's really nice of you, dude. Noise. Resident teacher Noise. You're welcome, Falcon, dude. Okay, so Arten said, if you were to throw a rock straight at a height above your head, it would return to your hand at the same speed at when you had released it. Would the same apply if you were to throw it in a classroom and the rock rebounded off the ceiling? I think it would have the same speed. Yeah. This has to do with conservation of energy. So yeah. So if you have like an object, right, and it's being thrown up, you have what's called kinetic energy, right, which is 1/2 mv squared plus potential energy, and this has to be constant. Okay. As long as there are no non-conservative forces acting, which is like friction or like things breaking. So whatever speed this is as it's going up, eventually it'll reach the top, and the speed will go to 0, so it'll have the maximum amount of potential energy, and then it will come back down. And as it comes back down, it'll lose all that potential energy and then gain kinetic energy, and it'll be the same. So this is the whole quote in physics, like what goes up must go down, right? It's the same thing with throwing things up and down. And if it bounces off the wall, that doesn't matter. That doesn't change anything. What's up, Ethan? Yeah.
See, that's saying there sometimes it is a lie, because there is one thing that goes up and never comes down.
What goes up and doesn't come down?
It's your age.
Wow. Reminded me of my mortality, dude. Yes. Oh, there is one thing that goes up and doesn't go down. It's your age. I like that, Ethan. That's a good one.
I've seen that from like riddle.
That's a good one. I like that one. That's good. Yeah, so what I was telling Artran was that like if the ceiling technically moved a little bit, like if it hits the ceiling and the ceiling like technically moves, it does, just very, very small amount. Then yeah, then some energy is transferred to the ceiling. And so what happens is that the ball will come down at a slightly lower speed because it's going to lose some energy. Yeah. Okay, cool. I think that's all the questions for today. Does anyone else have any questions? Let's do the Discord Nitro giveaway because I need someone to boost the server. I need 2 more boosts. Okay, so cool. Here, let's do it. We'll do was it spinner wheel? It has to be someone who doesn't already have Nitro. So who doesn't have Nitro? Do you have Nitro Sensation? I forget if you do.
I don't.
Ethan doesn't. Okay. I know Teacup doesn't. Falcon says I can boost. We like that. Cool. Who else? Who else wants to be entered in to win Discord Nitro?
There's no way I will win though.
Well, I mean, it's a 1 out of 3 chance right now.
Yeah, it'll go higher. And
It'll go higher?
yeah,
What's up, Sensation?
it's like a 33% chance I have to win.
Okay. All right, let's spin. Let's spin. Let's
Really?
spin.
Is that 1%
1 in 3 chance, dude. Let's see if you win. Who's gonna get it? Who's gonna get it?
Obviously, I won. I know I wouldn't win.
Oh, it goes to Falcon. Nice, Falcon. You were close. It was close. It was almost got to you. Cool. Nice job, Falcon.
It wasn't even close there.
Well, yeah, it's all good. Okay, cool. How do I get you boosts? How do I do it? Dun, 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 dun. I think I have to like send you a message or something. Okay, whatever. I'll yeah. You will boost AC. Yeah, dude, I love that, dude. Yeah, 1 second. Let me find out. Where's Falconer? There it is. Gift. Let's spread some Nitro cheer. Yeah, enjoy your gift, dude. You're awesome. Just like this gift. There you go. Yeah. Yeah, it comes with 2 free boosts. Yeah, so if you could use those 2 free boosts to boost the server, then like we'll be back on Happy Boost Land, and I'll be, you know. The problem is that so we have to maintain level 3 in order to get what's called like a custom vanity URL, and a lot of the people who find our Discord do it through that vanity URL, so it helps out to have it. So yeah, sweet. Okay, cool, nice. All right, well, thank you everyone for coming to office hours. Appreciate everyone with their questions and everything. Big thank you to our top subscribers: Sam with 22, Sensation Black with 5, Pen Center with 1. That's cool, man. And our server boosters: Moog, Noise, Obama, Teacup, Al Prince, and Jamarcus. Soon to be Falcon. Sweet. Okay, awesome. Yeah. Hope you guys have an awesome rest of your weekend. Awesome Friday. I will play Fortnite with you guys, right? Is that what we said we were gonna do? Boosted, dude. Yes, dude. Yeah, look at that. 16 boosts. I love it, dude. Thank you, Falcon, dude. Here, let me add your name to the list. Let me add your name to the list. Look at add your name. 1 sec. Where is it? Falconer. There you go. Yeah, sweet. We love that. Thanks, man. Okay, let me you guys want to play Fortnite? You want to play the new Fortnite that's coming up? I haven't tried it out. I heard it's cool.
I mean, I don't know if Fortnite's cool.
Oh, but apparently there's a Lego challenge or something, dude. I
don't
love
know what
Legos. Legos were like my favorite thing growing up. I absolutely loved Legos. Yeah, big fan of Legos. Here, let me 1 sec. We're not gonna play Warzone. I played some Warzone last night. It was okay. I don't know. I think the game's kind of Fortnite just does not miss, honestly. I will give that to Fortnite. Throughout all the years and seasons and updates and whatnot, like it's always good. They don't miss. Okay, here we go. Let's do that. And then here, let me make sure I'm streaming in the recess channel as well. Share my screen. Okay, cool. Yes, good. Go live on that. All right, and then let me. Where's my stream manager? 1 second. Creator dashboard. They make this also difficult sometimes. Stream manager. Yes, good. And then let's raid. All right, cool. Yes, thanks for coming office hours. Our next stream will be Monday. I might push it back an hour because I have students I have to help with final exams. But you'll see an announcement for that. So what we're going to do now, if you want to come play Fortnite with us, we're going to do that in the Recess voice channel in Discord. If you're in Twitch, just hang on tight. It's going to pull you into our actual gaming stream where you can watch us play Fortnite. Come play Fortnite with us. I give out V-Bucks all the time for like cool challenges and stuff. So it's fun. World of Tanks. I do need to try World of Tanks at some point. Send me the link to it. You know, I'll get it and play with you sometime, Falconer. I love tanks. Tanks are great games.
I can't. I can't play it because apparently it's so updating for me.
It's still updating? Okay. Well, here. Awesome. Okay, we're rating. So I will see you guys over in actual gaming if you guys want to keep playing. Otherwise, have a great rest of your weekend. Have an awesome Friday. And I will see you on Monday. Cool? All right. Peace out, guys. All right, let's see.